Hey everyone, my name is Jeff Ellen. I'm going to be doing a walkthrough of the installation of the Open Policy Agent on Kubernetes. Open Policy Agent, otherwise referred to as OPA, is a tool that allows you to verify structured data against a set of rules. More generically, it can be used to implement fine-grained access control within your web service. This is a follow-up to a post that I did last week regarding OPA. And before I move on to the installation steps, I just wanted to give I got a couple of questions, so I just want to clarify what OPA is. Essentially, it takes the request that a client makes against a microservice and validates that request against the OPA, or Open Policy Agent. The OPA takes as an input the payload that's being requested by the microservice, or requested by the client on the microservice, as well as one or more policies. OPA will then evaluate that request against the policies and then return a allow or deny message back to the microservice. And what happens is after that allow or deny message is sent, you are then given, the application is responsibility is to either allow that request to proceed or deny it. An example of a policy is, a web service put, the payload to this pet update put is the owner name of the pet, as well as the pet ID, as well as the user making this request. So traditional authorization, you might allow pet owners to make update to pets, but if you wanted to enforce a fine-grained access control, meaning only the pet owner is allowed to make updates to the pet, you can either code that logic into your microservice, or you can use something like OPA to validate that request. The nice thing about using an external service to validate requests is that it's external. It can be updated without changing your application code. It provides a lot of auditing capability and just general, flexibility in that it can be refined without actually changing your application code. So this is a rule. OPA uses a rule format called Rego. Essentially, given the following input, we want to ensure that when the input method is a put, given some pet ID, we want to know that the input path, which is the pet ID, the user is equal to the input owner. So if the user is not an input, the user is not the pet owner, we would fail this test, and this would be a deny message back to the calling client, being, in this case, when I say the client, I'm talking about the microservice, which is calling OPA, and then it'd be up to the microservice to determine what to do with that request, whether it's a situation where you flat out deny it, provide an error back to the user. Maybe it's an audit situation where you allow it, but you log it. However you want to respond to that policy, it's up to the application that's calling the policy server to make that decision on what to do. In the Kubernetes world, very similar situation. We've got the kubectl CLI, which is essentially calling Kubernetes API via REST. So whenever you do kubectl apply, it's essentially just calling a REST endpoint on the API server, which then can call the admission controller. Kubernetes has a concept of an admission controller, which essentially can be used to make a decision on whether placing this resource in the cluster is allowed or not. So the admission controller can then check with OPA, and then based on the decision from OPA, we're either going to allow or deny that request to place the resource in the cluster. Example of this, given a deployment. So we've got a deployment. This is just a very simple deployment. It's got some names, it's got some labels, some various other information, or along with a typical deployment. We have a policy that essentially says, deny the request to place the resource if the input metadata labels are provided, and if the required are present as well. So if missing, so we've got required labels is greater than the provided labels. It's very simple. It's just saying that, you know, you have to have a particular number of labels. If it's doesn't match, it's considered to be a failure. So basically, you're just saying you're comparing the number of labels provided versus the number required, and applying the correct logic back to the admission controller. Very, very simple, allows you to do some complex things to, you know, make sure your cluster is tidy, make sure your you know, applications that are being applied by your developers match your requirements. So I'm going to go through the installation of Hugo. Got Hugo on my mind there. The installation of OPA. And what I'm going to do in order to do that is I'm going to use Kind. Kind is stands for Kubernetes and Docker. And what that allows me to do is easily spin up a Kubernetes cluster inside of a Docker container. I can remember the syntax to do that. So creating a cluster, essentially what it's doing is it's spinning up a Docker container with all the resources that are required to run Kubernetes. Just give that a minute to start up. One nice thing about this is you can quickly create and destroy your cluster in order to, you know, kind of verify that things are, you know, if you kind of mess up your cluster, you just basically destroy the container and create a new one. If I do Docker PS, you can see it's just a Docker container. You can use the Kind command line to either delete that, which actually just delete the container, or it can, you know, just do the normal thing to delete a Docker container. So the next thing you want to do is just set that context to be your, just set that context up to use. Shows you where that it's running, what port it's running on, all that other stuff. So on the OPA website, they do provide a tutorial on how to implement OPA in Kubernetes. I'm going to walk through that. I also have going to have posted on my blog site some abbreviated directions, as well as a link to a GitHub repo. So some of the items where they make you type in YAML and whatnot, you'll be able to just you know, clone that repo and use the example. So what this example is actually going to do is use OPA to validate that when creating an ingress, that the ingress matches a whitelist. So essentially we're saying our input request, if it's an ingress, we want to make sure that if it's either a create or an update operation, want to read the host name from that ingress and see if it matches a valid ingress host. And where valid ingress hosts come from is essentially within the namespace that you're applying that ingress to. There's some metadata called ingress whitelist that determines which host names are allowed. You know, the host that you supply in that ingress will be matched via regex against that, against the host name that you're requesting in the ingress. So the first thing we've got to do, you know, they talk about here using Minikube. I'm using Kind. You know, this works as well in Minikube. So the first thing you got to do is create a namespace for OPA. All of our rules that are associated with OPA, all of the admission controller, the deployment associated with the OPA itself, all that's going to live in the OPA namespace. To make things a little bit easier on myself, I'm just going to set the default namespace in kubectl to OPA, so I don't have to remember to type OPA on every request. Because I'm not using Minikube, I don't need to include these two extra pieces of information, and then just set the context to OPA. So the first thing we need to do is deploy the OPA server itself, and OPA uses SSL to communicate with the admission controller. So we have to generate a certificate for the OPA server, and then apply the trust side of that certificate to the admission controller so that the two can communicate securely. I'm just going to use OpenSSL to generate a self-signed certificate. So first thing I gotta do is generate the CA key and then generate the CA certificate. The CN that we're going to generate is mission CA. That can be any value that you want, or it can be your own internal certificates for your organization. The next thing we got to do is create the server conf, which basically gives some information about how OpenSSL should generate the certificate. I'm not going to create that. I actually should have that already from my GitHub repo. So the next thing to do is run generate the server key, generate the CSR for the server key, and then sign that with the CA that we previously created. So now we're ready to create a secret that contains the actual certificate that OPA will use when it starts up. So just going to create the certificate, just passing in the certificate and the key. And then once we have the certificate, we can go ahead and create the admission controller itself. The admission controller, it's a fairly large YAML file. Again, I have that included for you. Creates a cluster role binding, a role. The OPA server needs to be able to read and update config maps. Essentially what it's doing is using the config maps for roles, so it obviously needs to read those. And it actually updates an annotation on the config map to tell us that a rule has been accepted and processed in the system. So if it's a way of kind of checking that rules are activated properly. Service, related to the service, the name of the service is actually critical in this tutorial. We've got the name of the service is OPA. If we go back up here where the server's CSR is created, you see the subject is CN is opa.opa.svc. This value must match the name of the service. This value must match the namespace. If you're familiar with how kubedns works, it's always the name of the service, the name of the namespace .svc. Otherwise, if that stuff doesn't match up correctly, you'll get certificate issues. All right, so I'm just going to apply that guy right now. So everything looks like it was created okay. The next thing I got to do is create the webhook configuration. The webhook configuration basically ties the creation of resources to the admission controller. I am actually going to, this is one of the files that I do need to copy in its entirety from the tutorial, essentially because inside of the inside of this YAML, we actually place the certificate that's used in the OPA server. So that way the webhook can trust that the certificate we generated previously is valid. And this just will place that certificate inside of this YAML file for us. So if we take a look at that, you'll see there's a certificate material inside of this YAML file. So once we get that done, right, well, actually, before we do that, I'm going to actually label, put an annotation on a couple of namespaces, and that's this openpolicyagent.org/webhook=ignore. This basically tells OPA that any resources that are in this namespace to not apply policies. So for both the Cube system and the OPA namespace, I'm going to tell it to ignore. And then I'm going to apply the webhook. Okay, webhook created. So if everything is good, we should see some activity in the logs, hopefully without any errors. This looks good. Sent response. Okay, everything looks good. So now that we have OPA configured and running, we got to create a policy. So again, we have this policy that I talked about earlier. It's basically says whenever you do a create or an update to an ingress, validate that the input request host matches a valid ingress host. And where that valid ingress host list comes from is from the namespace that the request is being applied to. So I've already got this rule saved out to my file system. I'm just going to create a config map with that rule. And then we're ready to exercise the policy. So in order to do that, I need to create two namespaces. The first is a QA namespace and a production namespace. In the QA namespace, this whitelist is going to be star.qa.acmecorp or star.internal.acmecorp.com. So any host name that matches, this is the whitelist that's used for the QA namespace. And in the production namespace, we've got star.acmecorp.com. This allows you to ensure that, in a particular cluster or a particular namespace, you're not applying QA resources to the production namespace. So I'm just going to go ahead and create those two namespaces. And we're ready to go. The first rule that or ingress that I'm going to create is based on this ingress OK.yaml. Basically applies to the production. We're going to apply it to the production namespace, and because the host is signin.acmecorp.com, it should be okay. It should go through. And then I've got a second one called ingress ban. I'm actually gonna, this would actually be valid for the production namespace, but it's not valid for the QA namespace. So I'm gonna apply, first of all, I'm gonna apply this namespace, the ingress OK to the production namespace. Everything should be okay. I should kubectl get namespace, or sorry, get ingress -n production. See that ingress is okay, it's ready to go. I'm going to create this other ingress, which again would have been valid for production, but it's not valid for QA. And we get a message back that says that this request was denied, invalid host ingress host name Acme Corp. On the get ingresses, and you'll see there's no ingresses found in this namespace. So it rejected because it didn't match the whitelist. I'm going to actually just go ahead and fix this up, test.qa. So this should actually be valid for QA. It should be able to be applied without any issues. And there we go. We see our host is created here. And then the last thing I just wanted to show you was regarding the config maps. We've got the rule that we've created here. If I do show labels, oops, now it's going to be kubectl describe config map. There should be right at the top here, open policy agent policy status is okay. If for some reason this rule wasn't valid or it wasn't being processed okay, you wouldn't see this annotation on that ingress ingress rule that we created through the config map. That's why the policy agent requires write access to the config map because it's updating the status for us. So that's basically it for the ingress. There's another policy that we can play around with. This one just basically makes sure that when we create an ingress, we're not duplicating an ingress. So you could have a situation with ingresses where two different applications request the same host path, and not whichever one happens to be read first will be the one that wins. So this rule here basically checks to make sure that there is no other ingress in the same namespace with the same path to the same host name associated with it. So just shows you the kind of the power of rules that you can create with OPA. Again, I'm going to put all of the YAML files up on the GitHub repo. I'll have a link to that on the follow-up post on my website. If you got any questions or comments, just feel free to drop me a line. And thanks for paying attention.